Assalamu alaikum everyone. My name is Hassan Talal and the topic of my presentation is hot wire form cutting machine. Here is the contents list. First, we will see an introduction to hot wire form cutter. Then we'll see the detailed layout. Then we'll move on to block diagram of the hardware. And then what is MKS board, its features, why the need was for MKS board was created, the connection description, size chart, cost and challenges that we faced. So here is an introduction to hot wire form cutter. In this slide, I will tell you about the background, core function and real life applications of hot wire form cutting machine. Background. Hot wire form CNC cutters exist in a variety of different designs. Their main function is to cut out a shape by moving a hot wire through the form. Each machine is only capable of cutting a specific type of shape determined by the number of degrees of freedom, workspace and overall design. Core function. The core function of hot wire form cutting CNC machine is to cut the form in any shape as programmed to the machine. According to our project, its function is to cut the form into airfoil shape. Real life applications. The real life applications of form cutting machine is used to create display letters, logos, etc. Here is the detailed layout. The MKS board, laptop, and first of all we have a laptop. Garble is a software that is used to load a hex file into the MKS board. Now the drivers that are used to control the stepper motors, we are using stepper motors in this project, are placed on the MKS board. The drivers control the NEMA 17 stepper motors that we are using and they further control the movement of the machine. We'll see a graph of how the machine can cut the form into an airfoil shape. Here is the y-axis, here is the x-axis. Let us consider that the machine is laying in this direction, like inwards of the wall. The wire that will be connected from this to this is called nichrome wire or nickel chromium wire. We can say that the wire is connected at this point. Here is the form that we are going to cut. It is usually a XPF styrofoam. The motors at the x-axis will move, the wire will move in this direction, and if the motors at the y-axis will move, the wire will move in the upward direction. So the motors at the x-axis moves and the wire moves in the forward direction, and the motors at the y-axis will move in conjunction with the motors at x-axis, so the wire can move in a shape like this. And this will create an aerofoil shape. It is directly related with aeronautical engineering and our project is a part of control engineering design. In this slide, we see block diagram of hardware, MKS board, DRV8255 stepper motor drivers, NEMA 17 stepper motor and CNC machine that they are connected to this machine. The MKS board controls the DRV8255 stepper motor drivers. The drivers control the NEMA 17 stepper motors and they further operate the machine. MKS board. MKS board generation L version 1.0 is a board developed by MakerBase. It was created before we had Arduino and CNC Shield. They were used differently and we had problems like overheating. The drivers that we use would burn. So the MakerBase company created a board that embedded both these things into a single structure, and we have the MKS board. The features are the Arduino Mega 2560 and RAMS 1.4, also known as the CNC Shield, is embedded in the MKS board. It supports 4988 driver, 8825 driver, TCM 2100 driver and 8729 driver and other drivers. The driver that we are using is 8225 for NEMA 17 stepper motors. The advantage of this board is that it has a better MOSFET tube, which has better heat dissipation and durability. It supports 12 to 24 volt power input to solve the problem of heat and power shortage of RAM's voltage conversion chip. The need for MKS board, so that we can have all 3D printing technology in one place. The first they started researching the technology in June 2011, and the first board was launched in May of 2014. Here we can see the connection description of the MKS board. This is the USB port. We have touchscreen ports or TFT ports here. This is the hot bed ports or extrudal thermal ports. This is the port for servo 1, 5 volt power input, aux port, LCD port. These are the end switches for X-axis. We can see X-axis here, the colors are the same, so that we have don't any issues in determining which axis is what. This is the Y-axis, which is in blue, the end stop for Y-axis, the Z-axis and the end stop for Z-axis, which are in green. This is the 24 volt power, 12 to 24, it can vary. And these are the points where we where we insert the drivers into the board. They are in line 1, 2, 3, 4 and 5. This is the size chart of the MKS board. All these dimensions are in millimeters. The size chart is necessary so that when we have to create a casing like we use in our project, we should know the dimensions of the board so that we can make a proper case. How the drivers are connected? In the previous slide I showed you how the drivers are connected in line. These are pictures of different drivers that can be used in an MKS board. The driver that we are using is 8225 and it is not shown here. Estimates of cost and assess time. This is the estimate of cost and assess time, and the time that item takes to arrive. There are 10 to 12 items and their cost and assess time are written in cost corresponding to them. I have mentioned mechanical parts here, which involve wooden sheets, rails, pulleys, timing belts, nichrome wire, XPS foam, nut bolts and L clamps. The cost of stepper motors was 3600. That took us about 2 weeks to attain. Motor drivers 2000 and that took us about a week to attain. MKS board, the price of MKS board was 3500. There are different types of MKS boards, like some can control 3 motors, some can control 5 motors and some can control 7 motors. So the price may vary, and it took us about 3 weeks because we had to ship it all the way from China. Jumper wires 100, power supply 500 and other miscellaneous items like nut bolts and screws, all of them took us about a day. The challenges. The challenge I faced was to get myself familiarized with what an MKS board is. Besides that, MKS board is not available in Pakistan so I had to get it shipped from China, which costed us a lot of time. We are still working on the programming of MKS board, which is a difficult task.
Questions?
Any questions?
स्टेपर मोटर का काम करते हैं।
हाँ,
स्टेपर मोटर की क्या लिमिटेशन होती है, कितनी जो आपकी उनके काम करेंगे?
वो वेरी करता है फ्रॉम स्टेपर मोटर टू स्टेपर मोटर. जो हम यूज़ कर रहे हैं वो नीमा 17 है और वो एक रेवोल्यूशन में अबाउट 800 स्टेप्स लेती है.
आपने जो MKS बोर्ड मंगवाया चला,
हाँ,
तो पाकिस्तान में क्या अवेलेबल नहीं है इसका?
पाकिस्तान में वो अवेलेबल नहीं है. पाकिस्तान में ऐसे आपको पता ही है कि बहुत डिफ़िकल्ट है अटेन करना।
तो आप उस पे काम क्यों नहीं कर रहे आर्डिनो के ऊपर वो लगा देते जो उसके
आर्डिनो मेगा और CNC शील्ड यूज़ कर लेते हैं उसके ऊपर।
सस्ती पड़ जाती है आपको।
वो सस्ती तो पड़ जाती है, लेकिन उसका इशू ये है कि क्योंकि ये स्पेसिफिकली इसलिए डिज़ाइन हुआ है, जो आर्डिनो है वो ओवर हीट होता है, उससे ये होता है कि या हमारी जो CNC शील्ड है वो बर्न हो जाती है, या हमारे ड्राइवर्स जो हैं उनमें वोल्टेज वेरी करता है और वो बर्न हो जाते हैं।
आपने इसमें ना पुश बटन की बात की है, तो वो क्यों यूज़
स्टॉप बटन एंड स्विचेस की बात की है,
एंड स्विचेस
वो इसलिए यूज़ हो रहे हैं क्योंकि अब हमारे अगर फॉर्म की साइज़ इतना है और अगर ये वायर आगे आगे तक जाई जा रही है, उसको आगे जाने से रोकने के लिए हम एंड स्विचेस इस्तेमाल कर रहे हैं।
Any other question? Thank you, sir.